Hey guys, welcome back. Topic 9, Application of Equation, Part 5. Now we're dealing with mixture and solution. So again, we're still dealing with more problems, but this time we're dealing with mixtures and solution. Mixtures are things, solid things. It deals with solid items, and solution deals with liquid. Those are basically the difference between them and some other things. But the same steps, the same way how we deal with them is basically the same. So to deal with them, we use a 4x4 chart. It helps us organize the numbers given to us so it's not all over the place, okay? So what's inside our chart? Well, we'll talk about our first row. So if we look at the second column, we have amount. So what is amount? It can be some kind of way or some kind of number, like counting number, like there's 5 of something, or it can be gallons. It can be gallons, ounces, whatnot. But it's in the word problem is the thing with units basically. If it has pounds in it, you put it here. If it has kilograms, you put it here. If it has gallons, you put it here, whatnot. Our third column is rate or percent. Rate deals with mixture, percent deals with percent. Percent deals with solution. So again, our rates will be given to us most of the time. We don't look for that. And our total will not be given to us, but will be derived from the previous two tabs. So how you find the total is you're going to multiply the amount times the rate or percent, and you get the total. And then let's talk about our rows. Our second row is our given. So most of the time you're given two things. Given item A, and we have given item B. And we're going to just plug in the things from the word problem here and here. And then this one will be mixture or solution A and B. It's going to be the mixture or solution of A and B, okay? So aside from this chart, you guys also need to remember that to get this item, to fill in this tab, you need to add this and this to get this. So basically, A, B, the amount of in the mixture or solution is A plus B. That doesn't go for the rate or percent. Okay, you don't add rates and percent to get your mixed rates or percent. This will be given to you most of the time. And then we have a total, which is TA and TB is equal the total of the mixture, the total cost or amount, or no, the total cost most of the time will be TA plus TB. So to get the amount in the mixture, you add A and B. To get the total in the mixture solution, you add total of A and total of B. Okay. Okay, now let's move on. Let's delete that. So let's have an example. So this might look daunting, but trust me, this is just one problem. Just different stages of the tabs. So let's get back to that. Let's get back to the problem. 4 pounds of cane molasses which costs £4, $4 per pound, is to be mixed with beet molasses, which costs $1 per pound. How many pounds of beet molasses must be mixed with the cane molasses to create a mixture costing $3 per pound? So what do we do? Well, what we do is we draw the chart and we start filling it out. So our given item A will be cane, our given item B will be our beet molasses, and then this will be our mixture. So I previously I just said it deals with solutions, liquid solution, but I think I'm wrong on that part, so ignore that. Ignore my opening statement. But it's pretty much the same thing, okay? Never mind. Let's get back to that. Let's get back to the problem. So let's fill it up things. We have cane molasses, beet molasses, our mixture, and then our amount will be pounds. It's right here, pounds. That's our unit. And then our rate will be dollar per pound. And our total will be pounds we have times dollar per pound. So if we look at the problem carefully, you're going to get £4 for your cane and $4 per pound for your cane molasses. And then beet molasses is $1 per pound. And then mixture is $3 per pound. That's basically it, right? And then we can also find the total, which is 4 times 4 is 16. So that's basically $16. So we have 1, 2, 3, 4. 4 things missing. So what do we do? Well, we're going to indicate things that we don't know with the variable. So here, we don't know how many pounds, right? We don't know. That's our question. How many pounds? So we're going to indicate that with a variable. Since we don't know, we'll just say, hey, it's a variable. It's x. And hence, since we know the pounds for the beet molasses is x, then we know the total, since it's just going to be multiplied x times 1, which is x. So our total for our beet molasses is x. Now how about mixture? Well, since we know what are f and x, what are our cane and beet are, we're not going to put another variable here right away. We should know our mixture. Since we're combining cane and beet, our mixture should be what? 4x. And then since we know the total is basically pounds times dollar per pound, it's going to be 4 plus x times everything by 3. Now that we've filled up all the spaces in our chart, we can finally move on to the last step. That is, what we really want from this chart is this total time. This is what we want. Okay. Likewise, how we find the total the pounds per mixture, we just add 4 and x. How to find the total for the mixture is adding 16 and x together to get this. So that gives us an equation. The equation is 16 plus x is equal to 4 plus x times everything by 3. Now what do? We do topic 8. We solve for x. So here's how we solve for x. Again, simplify things first. Let me write that down. Simplify. Eliminate smaller variable. Eliminate constant. Then eliminate coefficient. How do we get rid of that? We divide both sides by 2. If you do this properly, you're going to get 2 is equal to x. But again, since this is a word problem, we need to indicate what what 2 means. So we have to say x is equal to 2 pounds of beet molasses. So no questions? Not like you can say anything. Let's move on to another one. Hopefully in this part you'll get it. But if you don't, then just go back a few minutes ago, then replay that. Play it. Probably you missed something. So let's have another problem. In this case, we have 2 pounds of red apples costing $5.25 per pound, and green apples, which is $9.49 per pound. How many pounds of green apple to be mixed with red to create $7.45 per pound? So again, what we're going to do is fill in the given numbers and fill in the blanks too. So in this case, 20 pounds of red apples given, so we put it here. All the rates are given, so we write it here. Now, basically the same thing with the previous example. We indicate, since we don't know how many pounds the green apples will be, we indicate that with a variable x. And since we know 20 pounds is red apples and x pounds is green apples, the mixture should be 20 plus x. And since we know all these numbers, we can find the total. So 20 times 5.25 is 105. X times 9.49 is 9.49x. And 20 plus x times 7.45 is 20 plus x equals times 745. Again, what we really want is this last column or last row, because this gives us an equation to solve for x. And if you put it together, 105 plus 9.49x is equals to 20 plus x times 7.45. You'll get a good equation. And let's start simplify things. If you distribute 7.45 to 20 and x, you'll get this new equation. Now we eliminate the smaller variable. In this case, it's 7.45. So subtract both sides by 7.45. And you're going to be left with 105 plus 2. X is equal to 149. Now eliminate the constant, since we want x by itself. We want to get rid of the constant 105 by subtracting 105 on both sides. And you're going to get 2x is equal to 44. Divide both sides by 2, and you're going to get x is equal to 22. And don't forget, word problem, so indicate what kind of 22 is it. In this case, it's going to be 22 pounds of green apples. So you need 22 pounds, you need to mix it here to increase 7.45. And it kind of makes sense, right? It cannot be smaller than this because it cannot be smaller than 20 because the price will drop. Will drop lower than 5. And in this case, 7 is larger than 5, so x should be a bit bigger than 20. But I can only say that because I already know it's going to be 22 pounds. So just ignore the last part, my bad, if that confused you. Now let's try something a bit different. So let's say a wholesaler to make 27 pounds of mixtures of two kinds of nuts. Brand A costs $5.95 per pound, brand B costs $3.25 per pound. How many pounds of each kind must be used if the mixture costs $4.25 per pound? Again, we know, let's fill in the charts with the known variable, with the given numbers. So we know the mixture is the mixture is 27 pounds. We know all the rates, and we know the total is basically 27 times 4.25 times 27. We know that already, but we don't know what is A and B. In the previous two examples, we know at least one, but we don't know B and mixture, right? So what do we do when we have, well, if we don't know X, we don't know A and B, our two items? Well, we can use variables. You might think, oh, we're going to use two different variables. Let's say brand A is X and brand B is Y. But this gives us trouble down the line when we solve here, because we're going to don't know how are we going to solve for X if we have another variable in our equation. That's a whole kind of words that we don't want to do. So what do we do? Well, you kind of notice that from here x plus y has to be equal to 27, right? As shown here, x plus y is equal to 27. But the thing is, we want only x. We want variable x. We want only one variable in our row. So we need to get rid of that variable. So we need to find y. In this case, find is in quotation mark because we're not actually finding what is the value of y, but what is the value of y in terms of x. So what do? We're going to solve for y. How do we do that? Well, so divide both sides by, subtract x on both sides. We want y by itself, right? X is a constant in this case. So we need to get rid of that x by subtracting x on both sides. And you're going to have y is equal to 27 minus x. Now we find what y is. Find in quotation mark, since we didn't really know what y is. But the thing is, if you plug in this y into this, if you plug in 27 minus x into this y, you're going to get x plus 27 minus x, and if you solve that, you're going to get 27. So technically we did find so technically we find y, but not the real value. So that means we can replace y with 27 minus x. So instead of xy 27 pounds, we have x 27 minus x and 27. And then what do you do? Well, you do basically the same thing we did previously. Now that we know the powers of A and B, we should know what the total is. It's going to be 5.25x, and brand B is 27 minus x times 3.25. And then what do you do? Well, first thing first, now we have a good equation. 5.25x plus 27 minus x times 3.25 should give us 114.75. So now we solve for x. Simplify things, you're going to get this equation. Simplify the distribution you're going to get, and then combine like terms, you're going to get this equation. Subtract both sides by 87.75, and you're going to get 2.7 equals 27. Now divide both sides by 2.7, and you're going to get x is equal to 10 pounds of brand A. But the thing is, we're not done yet. The question asks, what are the pounds of A and B? We only know the pounds of A. So how do we find pounds of B? Well, we're going to use 27 minus x. 27 minus x is 27 minus 10, which is 17. So brand B is 17 pounds of brand B. So the first type of question and this type of question will appear on your test. So be careful on that, or be ready for your for that part. Now let's move on. Let's have another problem dealing with the same things with the previous example. In this case, we have 40 dimes and nickels worth 290. How many nickels and dimes do I have? So we're going to fill in the chart. So we have dimes nickels mixture, and for mixture we have 40. In this case, we don't need the dollar per coin because it's already given to us. The total for the mixture is 290 dollar per coin. Dimes is 10 cents, nickels is 5 cents, and then basically we do the same thing we did in the previous example. Dimes will be x and nickels will be 40 minus x. You might ask, can this be x and this be 40 minus x? Absolutely. As long as it can be, as long as it's 2 equal to 40, you can do whatever you want. You can switch it around, basically. You cannot do whatever you want. And then, since we know x and the amount and the rate, we can find the total, which is given right here. And since we found the three things we want, we now have a good equation. So again, we do the same things you do. Solve for x, and you're going to get 18. X is dimes, so x is equal to 18 dimes. And then we find nickels, which is 22. But the thing is, do we figure out how many dimes and nickels do I have? No, the question asks how many more nickels than dimes do I have. So how do we do that? Well, we're going to subtract 22 minus 18 to get 4. Minus 18 is equal to 4. Now let's do some solutions. So solutions, basically the same thing with mixture, but instead of rates, we're dealing with percent. And I think this is way easier than rates because we don't deal with decimals most of the time if you're careful enough. So let's try it. So let's say you have party and you're mixing 8 gallons of brand A and brand B. A contains 58, B contains 8% fruit juice, but the mixture is 48%. So how many gallons of brand B did you put in? Again, draw the chart. We have gallons, percent, and total. We have brand A, brand B, and the solution. Gallons is 8. Solution is, since we don't know brand B, it's going to be X. So the solution is 8 plus X. So for the percent, here's a good thing about solutions. When we're dealing with percent, you don't need to change that to decimals, okay? You don't need to change 48% to decimal, then you plug it in. You can simply put 48. You can simply put 48. You can simply put 58. You can put 8. No need decimals. This is why I like this solution problems. And then you multiply, you get the total of 8 times 58 should give you 464. X times 8 should give you 8x. 8 plus x times 48 should give you this equation. And then now that we have a good equation, we put it all together and solve for x. First thing first, simplify. We're going to get this equation. Now eliminate the smaller variable by moving it. So we subtract 8x on both sides. And we're going to get this equation. Now we want x by itself, so we eliminate 384 by subtracting both sides. And you're going to get 80 is equal to 40x, divide both sides by 40, and you're going to get 2 is equal to x. As you can see, it's pretty much the same thing we do in mixture. I keep repeating myself, but I want this part to stick it in. If you master mixtures, you should know how to do solutions, okay? And that's it for this video. Goodbye.